right. I believe we are live in high definition here now. Appreciate everyone for joining us today. We are hosting a session on fault detection and diagnostics, real world lessons for field service. So I am Terrell Whitson. I'll be your host and moderator today, and we'll do the best to conduct the fine fellows that we have present today. And we'll introduce our panel here. We'll take you through, some presented material. We're going to have some moderated discussion, some questions. We're going to look forward to your questions and any feedback and interaction we get from everybody. Please try to put any questions and answers in the Q&A session. General chat is for you. We'll monitor it as we can, but try to use that for your own kind of back and forth. But Q&A is where we're going to focus for coming back to tee up our panel of experts into areas that they want. We can dive in deeper and see where your feedback and elements are going to come into play. With that, brief background on myself. I've been in the facility engineering technology business for 25-ish years. Had the fortunate opportunity to be pretty heavily invested from the smart buildings and fault detection diagnostics perspective for the last 15, and many other elements, and most notably with my great compatriots over at CBRE and DB Engineering and our Microsoft deployment. But this session is about our other fellows here, and we are joined by Jessica Granderson from Lawrence Berkeley National Laboratory, and we're going to review in some elements some key findings and research work that she's and her team have published recently. Jeremy Richmond joining us as an international participant, coming in live from Germany. I won't even attempt any German greetings for you, so thank you, Jeremy. He is representing, there we go, perfect. He's representing MSIE tonight. Seth Pereira, some of you may already be familiar with. He was on the Smart Buildings platform session earlier, doing a fine job. He's pulling double duty, and he's joining us representing McDonald Miller Facility Solutions and their Smart Buildings team. Last but not least, Mike Bigelow from Seattle Children's Hospital. He's going to introduce us to us in a little bit regarding a successful deployment and some real-world application. But first off, we're going to turn it over to Jessica. She's going to take you deeper and relay some of the great findings that this paper has, we've all gotten to digest and examine. With no further ado, Jessica, take it away.
Thanks, Terrell. I'm going to get into, all right. Are y'all seeing the full screen mode? Perfect. Thank you. I'm delighted to be here in this conversation today. Jessica Granderson, I'm a senior scientist at Lawrence Berkeley National Laboratory. I am the director of the Building Technology and Urban Systems Division there. I've spent my career kind of working at the intersection of energy technologies, the people who use them, and the organizational practices that they're integrated into. And I'm just going to tee up some of our conversation with a few highlights of what we learned from analyzing 18 million rows of data on commercial building HVAC faults. Some context, I think we know that our national goals are aggressive. We've set about for economy-wide net zero emissions by 2050. That's, of course, inclusive of the building sector. We've got massive investments channeling into our buildings, vehicles, and grid infrastructure. And we recognize that we're in the pursuit of these goals, we're continuing a strong focus on efficiency. We're coupling that with electrification to reduce on-site emissions, to take advantage of an ever cleaner grid. The fourth component being demand-side flexibility to ensure that that clean grid is both affordable and reliable. These strategies or objectives are laid out, articulated very clearly in the DOE's national blueprint for the building sector. So a lot of our conversation, rightly, has been around retrofits. They're really critical to this agenda. We're talking about heat pumps and envelope retrofits and storage. What I want to pull out is that without attention to operations, we can lose the value of those generational investments that we're making in those electrified, flexible assets. So some of the largest ever studies from Berkeley Lab with the support of the Department of Energy have shown us just how much FDD technology monitoring-based commissioning approaches save. Whole building savings average of 9%, very cost effectively with paybacks of under 2 years. In that body of foundational work, we understood what can FDD, what can a monitoring-based commissioning practice save. We also were able to document common measures, and those are called out in the pie chart and bar charts on the right of this slide. A lot of controls related operational measures, a lot less, hard kind of mechanical failures. In the work that I'll highlight, we wanted to go deeper. We want to know more about the value proposition, more about effective O&M practices, and more around what we can do to continuously improve the state of the art in what we're making available to the market. So a few questions, what is the volume of faults that staff are confronted with? And related questions around which faults in our HVAC systems are most common and which are most enduring, which kind of last over time once they show up. We did this by collecting a ton of data out of FDD historians, largest empirical data set that we're aware of to inform a study of this type, over 1,200 buildings, all with more than 12 months of operational performance data from, over 60,000 pieces of equipment and systems. The first result highlight that I'll share is that around volume. So we found a median of 245 faults per building per month. If we normalize that, that's 3 faults in every air handling unit every month, 1 fault in every terminal unit every month. If you think about these large buildings, that's a heck of a lot of problems that are piling up. And what I want to call out is this wasn't just a short list of faults. These were several dozens of faults happening across each of the components in these systems. Immediately indicative of the need of the FDD technology, not just to identify the problems that are occurring, but to prioritize those that are most critical for attention and action. That might be from perspectives of utility cost, that might be around impacts on occupant comfort or equipment life. In this slide, I'm showing a multi-dimensional quantity around the faults that we found that were both common as well as persistent once they occurred. So kind of which are both of those happening for? And what I show in the blowout on the right are a few key findings. First, supplier temperature and airflow sensors, problematic. That has impacts on our ability to keep systems under control. It also has effects on diagnosability of other problems, which I'll speak to in a moment. So scheduled sensor calibration, maybe not every last sensor, but at least the ones that are most recurringly problematic is important. If we care about minimizing utility costs, those are escalating, as we know. We see the prevalence and incidence of problems with economizer sequences, also coil valves. So that can lead to expensive problems like simultaneous heating and cooling. Then the last insight I'll draw from this is, if we're trying to deliver on demand flexibility, we have a goal, an established national goal of tripling our demand flexibility potential out of our building stock. then it's problematic that we see all of these issues associated with static pressure and supply air temperature set point, as well as those supply air temperature measurement points feeding into our control algorithms. Last highlight I want to give, oh no, sorry, I have one more after this. The next thing I'll note is we kind of know from all of our collective experiences in the field that getting our economizers working right is a challenge. Certainly that was borne out by the data in this study. What I'm showing for you in this slide, if you look at the orange bars, 30% of the most common faults in our air handling units, as observed in the data, were relating back to the economizer. Last, I want to talk about diagnosability. In this plot, what I'm showing is in orange, what we call behavior-based faults. So we have condition-based faults. Those are things where we know the root cause, something like a stuck damper or an erroneous sensor reading. We also have cases where the FDD is really surfacing symptoms, something indicative of an underlying problem, like a set point not being met. Well, here I'm showing the most enduring, lingering problems across the data set, and it's all of the orange ones, these behavior-based symptoms. And so we got to think that that's because, it's taking operational staff longer to run down the underlying source. These are harder to diagnose. Now, I'm giving you, just to seed the conversation today, a couple of highlights from this work. This is a very rich body of work. So anyone who wants to really dig deeper and get into all the details, I show on this slide the publication title. This is in Science and Technology for the Built Environment. I want to conclude with a couple summarizing thoughts on what this says about where we're going. First, with regard to O&M strategies. Clearly, we need to be very intentional in establishing standard operating procedures around how to prioritize taking action on the problems that we identify. And that can be paired with procurement of FDD platforms that have robust prioritization features and functionality. Second, we saw those most common, most persistent issues around a couple key sensor classes, and scheduled calibration of those is important to bring into the mix. The volume and diversity of problems, really strong data-driven continued evidence that our teams have to be very well resourced to maintain continuous operational performance. We can do that through in-house expertise or outsourced to third parties. A few development opportunities already underway in the research as well as the technology and services product communities to improve the state of the art. And that's around, we saw it with all of those lingering problems that were symptomatic or behavior-based. We need improved diagnosis to support faster resolution, closing the loop on getting issues resolved. Second, and in that vein, we're looking to more software-based abilities to automatically correct or streamline the correction of specifically all of those problems related to the control sequences and set points. And last, I'll recognize that with this, mountain of faults that we may be confronted with, there's symptoms, there's conditions. We're seeing a lot of advances in the technology to do better for users in grouping those faults into related problem areas. And I think that's something to also keep an eye on. So I'll stop there and thank you.
Excellent. Thank you very much, Jessica. You said deep, informative research, and the analysis was very interesting for my own read. I like, the highlights of the different assets, the groupings, and I think that conditional based versus behavior based was a important distinction. It's something we can kind of carry that lens as we go to some of the rest of the conversation. Now I'm going to kick it over to Mike. He's going to introduce some of his findings at Seattle Children's Hospital, some of their applied results and successes. Hopefully, he will take us through that and show us, and we'll all have something to analyze and respond to from there. And again, if you have any questions, pop them in the Q&A, and we'll tee them up for later as we go. Mike, take it away, please.
Good afternoon, everyone. I'm Mike Bigelow with Seattle Children's Hospital. I run systems engineering. I'm a mechanical engineer by background, licensed in 4 states. I have a certified energy manager credential, certified commissioning provider credential, and lead AP, BD, and C. So when I got to join Seattle Children's, heading up energy and water efficiency to comply with the Clean Buildings Law, we were in for a bit of a ride, especially to apply many of these ideas that we heard about from Jessica and her team. We'll see actually showed up in our own fault detection and diagnostics training. So just as a bit of a level set, Seattle Children's Hospital at 1.6 million square feet, we needed to cut energy by about 20% in 5 years. We had just added a significant amount of space, and we had a limited capital budget. So something like a fault detection and diagnostics approach was key to our energy compliance strategies. So it started off with a pretty big ask, and we are pretty much at compliance at this point. The latest data is showing that in that 3 years that we began to implement this, we have actually gone and realized what many of the folks have been pointing out for a long time, that there is great potential in fault detection diagnostics paired with the right teams and the right processes. So we've managed to hit that compliance at this point. How this folds into facilities management is key, because although energy is top of mind for someone like me and many of the folks on this presentation, it is not the only thing. We've got a workforce that we're working with that is work order driven, and they've got their own metrics. They're very performance focused to make sure that they're closing out those work orders, that they have relevance, and they're actually surprisingly environmentally motivated. So we've got this wonderful combination of folks and these systems to work in that with the right approach, we've found success at Seattle Children's. So for ongoing commissioning, we first and foremost have had one program, and it had 3 major impacts. Ongoing commissioning supported by fault detection and diagnostics had to be able to generate work orders, and it had to also focus on that optimization and performance and show that reduced energy waste through data. The slide is going to advance here. Excellent. So because we were so focused on that facility requirement of actually delivering the right conditions to the hospital, making sure that we're minimizing waste after that initial ambient temperature had been delivered, that was a lot of our focus. Fault detection and diagnostics enabled us to go from a complaint-based or a work order-driven only system to something a little bit more proactive, where we had some data to bring to it. And surprise, surprise, set points, schedules, and sequences, just like we heard about in the research, we're scheduling advanced resets, are top of mind for a number of folks, and sort of our most optimal plays. That all came right out of the fault detection and diagnostics and retro commissioning efforts. But talk a little bit about that, why the technology and the analytics were so helpful in this case. It is that intersection of the construction space and operation space. It allows us to use technology and the excitement that's around that to drive some operational and process change. When you got something new, folks are excited to jump on it. They see it's a going concern. It's not the same old, same old. And we're going from that report on a shelf to a dashboard in your pocket. This was huge for Seattle Children's because we had a bunch of reports, but almost every time we got one, it was outdated information for the folks in the field, or it wasn't 100% relevant. So it was much more difficult to act on that. We managed to go ahead and borrow our IT compatriots process to deploy this. And this actually connected to our chief information officer's roadmap. The idea of getting broader support is also one of those great stories from Seattle Children's, that we had folks that were really excited for the technology piece to help us drive that operational change. So we got started first and foremost with an analytics pilot. Fault detection and diagnostics across the building is a big ask to go from 0 to 1.6 million square feet. That's huge. So we went ahead and started off with a smaller, more focused sort of floor by floor analysis. And it revealed $17,000 of waste on average, annually speaking. We got those work orders in the system, got it all corrected within 6 months across those 3 floors, analyzed, and we had those programming corrections in place. So there was already some successes to talk about from a financial perspective. This allowed us to go to a full energy management system, gathers building environmental data, leverages analytics at scale. This is primarily what we would call an expert system. It's just math. There's no machine learning or AI behind it. So it's very straightforward and I think fairly replicable and maps very well to what we've seen from the research. And it supports that high performance operation. In healthcare especially, we are doing things that require energy to do. You can't have an operating room without at least 20 to 25 air changes per hour, depending on where you are at. That's just what you need to have. So you need to have that first, and then you need to do that efficiently. And this is the approach that managed to make that work. So the fault detection diagnostics program we went with generated work order ready outputs. And this was huge to actually acting on these findings. It doesn't take someone like me with my background to go down and sit in a meeting and then talk to everybody. The program itself typically takes care of it for us. This integrates with our CMMS, that's the computerized maintenance management system. So we can import this information both into work orders for folks to act on and tie it to our assets for our asset management strategy and program. We can understand the costs that are going to the various assets and see if they're ready for replacement, or we can ask for more capital with some more confidence there. We put in a governance team to make sure that this was all working properly. We had the right processes around it, so it wasn't just going to be spitting out work orders willy-nilly and taking over our facilities management. Was folding into it because it had that human in the loop. And again, it was already building on the success of the ongoing commissioning program. So a lot of what we're seeing in the research, we're able to find the issues, prioritize that action, and with those resource teams, take action. So I'll go ahead and give back the share and we'll move on to the next presenters.
Excellent. Thank you, Mike. Appreciate that. Again, outstanding findings. I think it's important that we all collectively keep onboarding these successes and continue to evangelize to our community, the wider audiences out there, that these aren't, one-offs. This is the system. This is what buildings are doing. I know over time working with different companies, there's often a pilot needed, as you mentioned. We had to go prove it out. One thing I consistently keep coming back to is, if you go back and look at all these studies and you go look at the research that places, Jessica's team and LB&L are doing and others are doing, there is a mountain of proof. Every company that wants to come next always seems to want to replicate the proof. Well, let's see if it really works. We'll talk about that more. And I'm curious to see, Jeremy, Seth, both of you two have been heavily involved in deployments of fault detection systems, smart building platforms, as Seth was speaking to earlier, Jeremy as well. And that, with your experience, related to various firms and various types of clients, can you go ahead and expand on that? Introduce yourselves, your approach. I'm going to start with Jeremy, and then we'll bounce over to Seth. Give us a little bit of an overview, Jeremy, and kind of take us a little deeper onto some of the experiences that you've seen that relate to what Mike and Jessica have told us about so far.
Yeah, absolutely. My background comes from operations. So I worked in operations for, 10 to 15 years-ish, as everything from a control tech all the way up to a chief engineer running commercial real estate before really picking up, I would call it the smart building bug. And we were doing smart buildings in 2009. We just didn't call it smart buildings, right? We weren't using software. A lot of times it was all manual analysis, figuring out what was going on and working through it. But leveraging software to do this, now going forward for the past, another 10, 12 years-ish. A bit I've had a lot of, I don't know if I want to call it failures in this process as much as learning opportunities, learning things, right? So, one of the big things that I've always seen, whether from client to client to client that I've ever talked to, worked with, even some that I implemented them for, and we turn on a system that's got great analytics around, as Jessica mentioned, in some of the economizers or some of the other equipment that's happening, that has problems. And what we find out is we have now all of a sudden 47,000 faults that showed up today. And we went, whoa, what are we supposed to do with that? So how do you find the gem in the sea of the noise? And then, the products that are in the marketplace have gotten a lot better across the board at filtering through that noise to get things that are more turnkey, but really kind of getting back into sometimes the problem that shows up on the screen around an economizer, maybe like an overcooling fault, right? And it could be a sensor, issue, could be an actuator problem, could be a linkage problem. There's about 4 or 5 different pieces that could cause that. And being able to see the operators evolve to understanding that, hey, instead of me telling you that this is a broken economizer, that this is a type of problem with an economizer, and that economizer should be investigated. Right. So I feel like that was a missing link for a long period of time. And even as late as the last few years, where I worked with a client who put a system in and just expected that their operators were going to just take action on things.
A little bit of the connection as to Jessica's paper around the condition based versus behavioral based. Things that are directly indicative and things that may be systemic or caused by other symptoms, right?
Right. And it's those other systems that, and I'm not going to say more often than not, but with some likelihood that you shouldn't exclude those other things when looking at, okay, I'm going in to look at my economizer. The fault detection system said my economizer was broke. Well, when you're out there and actually investigating it, and our operators that we have in our facilities are incredibly talented. And so when they get there, if they focus just on, well, the work order says the economizer is broken, sometimes we need to expand that concept of what we're trying to fix, which is the economizer is not performing as designed. Investigate X, Y, Z, right? Because you might find out that the real problem is that $2.60 pencil probe that's in there just needs to be replaced.
Yeah, exactly. And that's where, I've often advocated that with these systems, this isn't about, superseding or replacing all the competency and the wealth of knowledge that we have in our technician and leadership base. It's augmenting. It's simply another tool in the box that shines a light on what you're trying to find and points you in the right direction, hopefully, to go. It's not just the economizer, the open close. It can be all these other things. Pursue down that path.
Right.
Awesome. Thank you, Jeremy. Seth, you want to tell us a little bit about yourself and some of your experiences deploying FDD in the real world out there?
Yeah, thank you so much. So Seth Farrar, I'm the Smart Buildings Program Manager here at McDonald Miller Facility Solutions. We're a design, build, optimized company who leverage our system experts in order to make sure that we're able to not only design and build and install the best systems, but we also maintain those systems over the life cycle of a facility. As spaces change, you need to make sure that you update those spaces, especially if you are leveraging an FDD tool. These FDD tools work off of digital models, making sure that they understand how they're supposed to be analyzing the system up in the cloud where a lot of this data stays. And so when you go and you change spaces, you have to make sure that you're also maintaining these tool sets to ensure that you're getting the return on the investment of getting those in there. So what we're focusing is, one of the things that Jessica pointed out is, we have a national goal to reduce energy. We have a lot of buildings in the country, and there's a lot of people who can benefit from a tool like FDD. So what we are focused on is getting FDD tools scaled across, entire industries, entire regions, making sure that it's great that Seattle Children's Hospital is leading the way here and getting these tools in place and showing, the rest of the region partners how they can operate these tools. So getting the message out there that, Jeremy mentioned that the tools are getting better, they're more sophisticated, they're cheaper to install and maintain over time. So it's really gotten to that point now where we can start to leverage a lot of other partners within the region in order to get these tools deployed more globally. So that we can achieve these very optimistic goals that we have for energy reduction.
Great, thank you, Seth. Again, I think you kind of see the breadth of experience across the panel here. We're gonna pivot in and move forward with the rest of our moderated discussion. We've got some questions teed up, but I will ask the audience if you've got questions related to fault detection and diagnostics, to FDD deployments, and even so far as, smart building technology in general. We have wealth of knowledge here to draw on, so feel free to drop them in the Q&A. We've got a few, thought exercises to work through ourselves. So with that, I'm going to tee up Jessica. The paper does a real great job at kind of putting a lot of the categories together, but highlighting, with the asset breakdown at the air handlers and the ATUs, and really quickly seeing your fault count per month, your fault count per asset are all extremely high. Paralysis by analysis is real in the FDD world. All of those of us that have deployed and launched always get the sticker shock when we see that those first numbers start to roll in. With the analysis that you've done, how do you feel like some of these categorization and the highlighting analytics start to help maybe decipher and take some of the sticker shock off and scare for operators in the future?
Indeed. The first comment I want to make about all of this is to kind of take half a step back and think about like our approach overall and opportunity to kind of shift how we're going about these activities. What I mean by that, it used to be like, since we've started doing FDD for buildings, and kind of like the MO has been get the most data that we can, analyze it according to a library of the most, all the rules we could think of that are applicable to that data and all the problems we might be able to surface. And I think what we're seeing now is a lot more opportunity and in focusing. What are the biggest problems that arise? What are the most common problems? What are the most diagnosable problems? And how do we focus on those and make sure that we're then able to connect the dots and get those problems fixed? We already know that there's like high cost impacts from all the problems with scheduling, economizers, rogue zones, absence of strong resets. Well, let's start there. That's really where we need to be going. So that's just kind of a paradigm shift from like seeking as much insight as we can to just narrowing our attention to the most actionable, high impact problems and getting them fixed. Second, I want to double down on the comments around operational management processes and formalizing them. It doesn't have to be perfect. It can evolve over time, but certainly what we know from all of our collective experience, it can't just be ad hoc, just kind of like waiting for that shock of the problems to start rolling in. And that's where, being able to rely on some of the prioritization functionality of existing systems is important. It's kind of with our faults in our buildings, it's like it's like the opposite of programming. like any coders out there, is like fix one bug and like now you have 10 more.
Mhm.
But I think in buildings, it's like fix one problem and you're gonna see a lot of shrinking of the list as we go. So, you know, focusing on the fact that many of these issues are interrelated and connected, you probably don't have as many as you think you have if you're just going line by line by line, looking at all the rule violations we could flag.
And top down versus bottom up on some of those faults too, where you can
Yeah.
find some of those source endemic kind of faults that cascade through the system. One of the worst things I remember hearing somebody, it might have been at a conference, that they seemed to be fishing about, well, what about this FDD system and that FDD system? How many fault rules does that system have? And how many fault rules does that? And they were comparing as if that was a quantifier of success, was how many fault rules a fault detection system had. And I found that to be pretty flawed thinking. How good are your fault rules? And that's a key piece, is how effective, how consistent are they? I'm gonna take that. We're gonna jump into a question from the chat. And I think this relates maybe a little bit to one of the conversations we had yesterday. I think it was Vivian and one of the other sessions on IAQ, I remember. By decoupling ventilation from heating and cooling using a DOAS system, certain types of faults, such as those associated with economizers, traditional HVAC, are reduced. Have FDD tools been developed for DOAS systems? Panel, anyone want to take that in your experience so far?
Yeah, we have deployed FDD onto DOAS systems, and
Very good.
those systems have the same kind of checks that you can program in and do like you would on an economizer and air handler. There's still components that you're wanting to make sure are operating from day one all the way through the life cycle of that equipment.
Yeah, and I don't know, I'm speaking from my experience. I think there were, legacy systems that were traditional VAV and air handler VAV systems, medium pressure ducted systems. DOAS has come much more prominent with code changes in the last 5 to 10 years, maybe, at least in this region. We're probably have audience members from wide regions. I'm in the Pacific Northwest, and economizing was a great thing. DOAS was new, but now we're trying to have to decouple those two. I think in many cases, you're seeing it's similar tool sets, just a slightly different perspective around the control methodology there. Anyone else follow up? Otherwise, we'll take another question. Are there universal codes like automobile diagnostic codes that FDDs of different brands share? Oh, okay. This is one I would love to see. I know, Jeremy, you've got a wealth of experience getting to see a wide array. What are your thoughts on this? And is this a
this
vision
one
of the
would
future?
be awesome. And I'm actually seeing more of a shift in some of the manufacturers of like packaged rooftop units. And even central plant applications. I won't call out the manufacturer intentionally, but they're actually starting to create some of these analytics within their own systems. And so they report out, just like they would report out an alarm code, right? Yeah. They're reporting out a fault code. And then that fault code maps back to a bad economizer, or economizer non-functional, or something very generic that will give a technician something that they can go and check and do. But it's very ad hoc-ish, very alarm based type activities. But that's the closest thing that I've seen. But I say that with the flip side of that equation being some of those manufacturers, not all of them, but some of them are now requiring an extra service in order to gain access to those intelligence, or you have to connect those systems to their cloud product, their SaaS product, in order for you to gain that intelligence. As a fan of very open source technologies, that doesn't sit well with me, but there are pros and cons to both of those. And so just having the educated conversations with the owners about what putting all their eggs in one basket versus decentralizing, what's the risk to them? If that's going to solve all your needs to connect it to that platform to get those fault codes, perfect. Let's do that. Right? There's no need to make it more complicated. But we're getting there, but the industry is not there yet.
Yeah, unfortunately, I think that the idea that centralized automobile code type diagnostic codes, you have them for a manufacturer per manufacturer basis in many cases. Integrating those assets into smart building platforms have not necessarily come full circle. I think you'll see
Right.
development in ontologies and schemas that are out there. They start to centralize and unify the methodology that these systems speak and how those faults and asset relationships are defined. So Horizon, and one of our questions we'll come to in a bit. One of the things I want to do is do a little future forecasting, where, FTD can go tomorrow. But we'll pause there. What in current situations are there software, if there are software faults, are FTD tools able to detect them? I don't know, Seth, or maybe you probably got some experience with seeing these on some of the systems you've deployed.
Yeah, so the way I heard that question is like a sequence of operations fault, right?
Yeah.
That is definitely something that are built into these systems to be analyzing. When a lot of these systems get stood up, it is the sequence of operations that is going to be analyzing against, right?
Agreed.
So you're going to set up your faults to make sure that you analyze per what was designed. What was designed and what was actually implemented might be different. We're all human, people make mistakes. Maybe you put the wrong number in your set pointer or something like that. We have faults that are able to capture that and make sure that people are aware of that.
Mike, using that raise hand feature, I love that. Go ahead,
Happy to
jump.
help.
Yep, jump on in.
And to rip off some of Seth's points there, because yes, there is that align with the design idea, which is foundational to these. The software can also detect things like if your sensors that are going into those sequences of operations are out of calibration or potentially feeding bad values.
Yeah.
So the design could be good, but the inputs to that well-tuned sequence could be off. It also could find a difference between the design intent and operational reality. Things change over time, demands change over time. And those are some really good conversations to have about where that sequence might need to be updated to meet the new demands efficiently.
And that's a key factor, I think, in an FTD system that's capable of being able to reference design demand or design parameters and design characteristics, not just current operating characteristics as its assessment base. I think a lot of this feeds back in when we were talking, Jessica, with the behavior base, that they can be system, it can be all the way through the system. And so software faults, as you were relating, are almost our biggest driver, correct?
I would agree with that.
Yeah. It just they wind up being, they feed into so many other things. So I would say to our question that was posed that absolutely sometimes they're harder to get to the root, but absolutely software faults are well within the FTD capability. We've gone through a couple of different ideas about how do we work down to root cause diagnosis? How do we get to the source of the problem? Mike, as you've gone through and you've had some success with your sites with Seattle Children's, can you kind of take me through a little bit of the success criteria? How, you kept from being overwhelmed? How did you, get to some of your root diagnosis as you went through your batch of faults?
Solid question. And it's very pertinent because the folks that I'm working with to solve these problems, they don't work directly for me. I have to get their time. I have to advocate for the resource.
Yeah.
So we have to be very precise with what we ask of these folks. This comes in two fashions. One, we selected a fault detection diagnostics platform that was capable of projecting the economic impact of the faults that it found and would group these faults together by either asset or commonality. So if we needed to fix a certain fault that was across all of our VAVs in one section of the building, we could group it together like that. Or we could associate all of our faults with one air handler. When that was down for maintenance, go ahead and execute that work. So that was part of our selection criteria, is making sure the software could talk about the financial impacts and group the data in those two different ways, by mode and by asset. So that helped us save time. With that, we were able to build in a process where on a monthly basis, I and a couple of super users would sit down and go through the pre-filtered opportunities and say which ones we could and could not go after, because there could be upcoming maintenance that we could piggyback off of, great candidate. Or it could be, hey, that is going to be too impactful, we can't get access to it, so we'll put that one in a parking lot and execute on it when we can. So it's that people process to make sure that these opportunities have the right folks that are given to them and the right resources to go execute. And when they are executed, we'll also go ahead and check that out, see it in the data, and celebrate it. I got to give great credit to the team. Since January, we've already seen over $170,000 in savings. And this is just wasted energy that has been stopped at its source and optimized.
Excellent. That's good to hear. And it's those things that keep us all going, and we hear those successes get on the wall and keep celebrating them. You mentioned, I think, a great point there, in that, often within, whether or not you're a consultant, an engineering firm, a research, research organization, we're coming in and having, as part of an overall organization, and you're not often the sole source executor. I know one of the sessions earlier, there was I think almost everybody on the panel unanimously said a system champion was the most important thing that they wanted to have. Organizationally, as each of you have worked across, whether it's in gathering information and bringing it together into research or system integration to stand up, how have your organizational engagements and those relationships succeeded or impeded you? I don't know if any of you have an example you'd like to relate. I'll leave it to you. You want to throw out there? Good engagements or relationships when leaning into the organizations. I still feel like this is still one of our biggest pieces, that it's the secret sauce almost.
I can talk about what I've seen.
Jeremy, then we'll bounce back to Mike. I know you had one there. Jeremy, go ahead and go.
No, so sticking with the theme of real world lessons, right? Real world lessons. Worked with a client a number of years back who implemented a FDD solution across roughly 3.5 million square feet of commercial office space. That client had a champion in the FM team leadership saying, this is going to be great. We're going to change the world. It's going to be fantastic. Okay, that was in the FM leadership, not the FM team. But there was no champion in the FM team. And so a year and a half goes by, and then I get a phone call saying, hey, we've got this thing going on. Do you think you could come out and see what's going on? And immediately, one of the top things that needed to be addressed right away was change management. And it wasn't, for technology, it was for people and process, because there was none. All they were given, the entire FM team was given a dashboard that had a lot of noise, but with a slightly trained eye. You didn't have to be a super user. You could look at this and find nuggets of, oh, there's a problem here, there's a problem there, there's a problem there. And again, this is 30,000 entries coming in per day, kind of cataloging down statistically, so we could kind of see things. But one of the very first things we had to solve for was people and process, because there was no champion within the FM team. So we had to build a champion. It wasn't like soliciting, hey, who wants to take this on? Because they all looked around each other at the room and went,
who's got time?
So we had to build one and say, okay, who was going to be the most knowledgeable, who gravitated towards it the most. You know, they eventually, a few years later, put out a rack and actually hired somebody in to be that champion, but we had to make one internally within that team. Technology in and of itself will not change people. They need to want it, they need to have it. And I have seen time and time again where a leadership or C-suite level hears a buzzword and goes, "Oh, this has got AI in it. It's going to be great." And we look at it and go, "It doesn't really have AI. It's got an ML model to predict weather tomorrow, so somebody calls it AI." Well, that's, you know, they're not wrong, but they're, you know, it's a little bit of snake oil. So you got to be able to see through some of that and get to really what's there. So, Mike, I'll let you kind of chime into that.
And Jeremy, my experiences are very similar to what you outlined. If you don't have support from the folks with the purse strings up at the top of the organization, you're not going to go anywhere. But that doesn't go very far if the folks down the chain don't have that incentive, that space, the resource to do it. My personal experience at Seattle Children's, we did have a couple of folks that were very excited about the technology and the space. And when we had that announcement, hey, we're going to get this, we had those folks step forward a bit. We then had to make sure that they had the space to keep doing this and that those successes were celebrated. So in a similar way, we had to build from that foundation, like you mentioned, making sure that everyone throughout the organization got what they needed and kept the program going.
I'm maybe piggyback on a little bit of that and bring back something that Mike touched on that's really important. We talked about prioritization capabilities and being able to attribute an energy cost impact to the faults. We're also talking about fundamentally aspects of like accountability and being able to get credit for the work we're doing. Well, that same software capability that Mike's talking about, and he did say and speak to how you can then turn around and say, yes, and when I fixed this, I then saved this much, and that kind of tricky duality between like avoided costs and so on. And the software gives a quantification of that. The second thing I want to mention is around, you know, it's kind of like what are we accountable for in our jobs are and harnessing different value streams based on that. I think one under-recognized, underutilized capability of these software tools is it's not only and exclusively about the energy or the comfort and making, you know, minimizing trouble calls. When you look at some of those capabilities, they also tie directly to streamlining more kind of routine maintenance processes. So we're doing things like being able, like if you think about what those are, it's like you see things all the time. Go in and check the actuators, check the sensors, check the temperatures across a coil. And so bringing, I think, some of that also into play as we consider, we have so many different roles and responsibilities from sustainability and energy management facilities all the way down to, you know, large equipment operation. So I think we need to do better also at fleshing out those other ways that technology can be valuable.
I think that's very important. And, you know, collectively, we've had a great series of panels across all of SPX the last 2 days. And I know myself, I learned a lot. I know one of the sessions yesterday on IAQ and some of the other KPIs. A lot of us that had come in early into the FDD world, we had laser focus on energy maintenance optimization, but over time, FTD is a great engine and concept and tool that has many other functions that can get into. Our parallel session going right now, ESG, environmental, social, and governance. You have aspects at this that you can generate KPIs and fault algorithms that are going to support use cases where all of these things can be substantiated. So with that in mind and the wide world of future cool capabilities in our FTD systems, one by one, I'd love to get your, your top items that in the future of FDD, what does it look like? And what are your must-haves that you'd love to see coming in the next 5 to 10 years at FDD and wider smart building platforms? Seth, you want to kick us off?
Yeah, thank you. I think one of the things that I'm really excited for is the ability to have the systems autocorrect some of the issues that are popping up that can be just corrected with the software, right? You have it programmed in a way that it understands exactly what's going on, and there is very low risk to letting the software just move forward with that auto correction. Not having to get a person in between the issue and the resolution, I think, is a very powerful way to reduce all of the amount of faults that are coming in, and really just elevate the ones that we need people, because we will need people, right? This is a great tool. It has a lot of use cases, and it can do some things by itself, but we will always need people to take care of a lot of these issues. So being able to, again, just get rid of more of the noise and let the software be able to do the low level, low risk items by itself, and then just elevate the impactful items that we need people to get out into the field and fix.
That's huge. And I think that is, that's definitely some of the future casting that I'm, we talk autonomous operations, autonomous correction, enhanced continuous commissioning. There's a lot of cool buzzwords, but the reality is, can we get there to where we can start to clean the slate of these 10,000, 50,000 faults without having to put an operator touch on every single one of them? Mike, your thoughts, what do we got in the future? What does it hold for us?
So the future, I think, is going to go along the lines that Seth talked about for sure. We're going to have more of these autonomous capabilities. And I'm looking forward to that same idea, Seth, where we have that auto correct or auto push feature. That'd be wonderful. For me, I think fault detection diagnostics is going to evolve into the realm of reliability in the next few years. And this is playing off those ideas that we talked about with data we already have being put to other uses. The filter example is top of mind. We know when it's dirty and it's wasting energy, but that's also an indicator that expensive labor needs to be deployed to change it. So it's getting that idea built into the next round of fault detections and diagnostics.
I think that will be huge, is that just having that capability. And in some cases, I think I've heard it in this session, I think Jessica's mentioned it, censoring. Filter capability needs to be supported with censoring. We need to ensure that we're not, well, I think it was maybe it was Poppy in the morning session, that we're not, piecemealing and micro assessing the cost and validation of every single sensor. And it's a complete holistic package that these systems need to be able to reference. And in that case, you make a case for reliability. And that's why you're going to want some of these functions. Jeremy, what do you have for us?
Yeah, so where I hope we go for where FDD systems are going to go in the future is that we're going to be able to bring in some more kind of generative AI analysis into these systems when it gets a little easier to get data into a site-specific implementation and question. It's still a little complicated, but and the reason for that is the power for a user to be able to ask questions of those systems that are in there, just to be able to ask, hey, what I've got, I think it's going to be empty in the building on Friday. When do you think I could start load shedding? Right? To be able to ask it a question like that and be able to have it return an intelligent answer, because that system is connected to the occupancy tracking system that's in the building. It's connected to card swipes. If it's a turnstile in and out building, it's connected to the weather pattern, right? Like, to be able to ask it some of those types of questions. So as an operator of a building, if I'm trying to be a good steward and figure out different ways, I'm trying to come up with different ideas. Well, maybe I can start to shut off certain floors because there's not going to be people there, right? Or like if I have a huge cafe in my building and the system knows that it's going to be, 80 degrees outside and that the patronage in the cafeteria is going to be pretty low, can we start to do some DCV reset in there? Because the system might know that, hey, we're not going to have as many people in there. And so we can start to kind of edge back a little bit on being able to get incremental savings in different areas. So I'm really looking forward to generative AI coming into the space more. I hear everybody's got an AI tool and an FTD system, and I use it. And
Yeah.
I don't think everybody's got an FTD tool and an AI system.
No.
I'm sure there's some that are out there that I haven't seen. I've seen a lot of them, but I'm looking forward to the day when that's just commonplace.
And I think to your point is that, monetization of the system's key for them to get out there and be in front and to win the buzz war so that their product gets forward. AI is a very well claimed capability across many of the platforms. ML is most of the foundation. Machine learning is most of the foundation under the hood of a lot of those. But future casting, absolutely, that capability to stay ahead of the game and leverage it. And we've been pretty light on our use. I don't know we've done well on our AI bingo today on putting enough counts on the board for our session.
Do I get a full line now?
Yeah, we might need to, we need to keep the AI total going up. We got to push those numbers up. But it's going to be somewhere in our future. It will become part of the roadmap. And with that, Jessica, you have an amazing organization that is looking at the wide world of us, understanding it. You have a whole bunch of smart people right there in the building. I'm really curious to see, what do you think and what are you hoping is going to be part of the FTD of the future?
Well, I'm delighted to hear the comments around autonomous correction, autonomous commissioning, and the fact that that's on the horizon. I dropped into the chat for everyone a website that catalogs some of the work that we're doing with the industry to bring that to reality now. As an example, Coppertree has commercialized a new product just this year around these capabilities and through partnership with our team at the lab. And there is more to come coming down the pipeline. That's really about, though, just kind of taking a step back again, is really about integrating in single platform and product the capability to have a foundation of very robust analytics that's coupled with control capability, supervisory control. And folks who know the industry and the landscape know that those capabilities have been independent in product, like never the twain shall meet. So we're changing that in the work that we're delivering today. So it will be no longer automated fault detection and diagnostics, but automated correction and fault-free optimal control. So that means also, deploying our advanced up-to-date sequences, whether they're resets or whether they're demand flexibility. I guess I will add in, Terrell, you mentioned quickly earlier in our conversation, ontologies. I think that's another area to highlight, a very enabling innovation that is being worked on now to bring up. Is all about more rapid configuration, provisioning, and standing up of these systems. So when we're able to converge the efforts and get market adoption of things like ASHRAE Standard 223, the work of BRIC, the work of Zeto, bring those together, then we're able to layer our data with semantic enrichment that allows these algorithms to kind of automatically configure in a way that will remove much of the bottlenecks in getting this stuff going. I'm very excited about that. Overall, I think we're in an era, as all of my colleagues here on the panel have highlighted, of real step change advances in deployability and value add capabilities. And that's happening in a policy and incentive environment. If you think about building performance standards or all the buzz around VPP and demand flexibility, that is really centering the as operated performance of our existing buildings. And those are some of the headwinds that we need.
Yeah, and I think, it touches on a lot of some of the other panels where, there's a lot of performance standards now that are giving us headwinds to people want these things. They're going to need these things. Here in Washington State, House Bill 1257, the Seattle Clean Building Performance Standards, all of these are applying a little bit of that extra pressure to owners and operators that they've now got to pay more attention to it. We've been advocating for years. Now there's a little bit of extra emphasis coming from the municipalities and governance side of things. All right. We have a question in there, and actually I think it's a subject I would like to. We have 10 minutes to go. I want to kind of make sure we get any other questions coming out of the audience. There's one in there I think I'd like to unpack a little bit, and the question was posed as what skill sets are required for selecting a project champion. Jessica, you answered it, so I'll let you kind of, if you want to reflect your answer and then key up. One piece I'd like to take out of this is not so much just if you're a company and you're looking for your internal project champion, it's also taking this one step into the workforce. We've heard about this in some of the other sessions, is that I think there was a session earlier and they were talking about, if we're trying to hit some of these goals that are on the roadmap. 2030 is early benchmarks for certain aspects. 2050, a lot of organizations and major targets out there for a lot of the elements of what we're trying to address in the industry. So not only what are the skill sets for our project champions, but what is it in the industry that we need to help support wider use of FDD and smart building platforms?
I'll defer to Jeremy to unpack his answer around skill sets of a champion, and then I'll.
Oh, that was Jeremy. Sorry, I thought that was no. I thought that I saw the J and I overrode that. No, Jeremy. Okay, sorry, that was Jeremy. Go ahead, Jeremy. You take that one. You put a great response in the chat. I just want to make sure everybody that on the call, it's recorded for posterity, and you can build on that.
Yeah. So one of the things that I have found across clients is that the most effective champions that I've had are not the most technical. Some of them are very technical, but if I start to look at like a common theme across the board, it's people who have a passion and drive, who are okay to say, well, maybe we shouldn't do it this way anymore. Right? Like those are the type of people that I have found to be the best. Sometimes those people are very technically oriented, like Mike or Jessica, right? You have other people that have almost no FM experience or no operational experience, where they worked as a data analyst, right? But they come in and they just have this role of, they've got a passion for, hey, I get where this is trying to go. I get what we're trying to do. We're trying to reduce our energy. We're trying to be better stewards of what we're given. So how can we do that with these tools that are with us? And knowing that those tools aren't always perfect. And so you have to find, ignore the flaws is not the right term for it, but address the flaws with that vendor, but also take the highlights from that and action on those. Having a good understanding of the FM process definitely helps, because if you know that the technicians during day shift will never fix a work order because they're going to have to set up isolation carts, they got to get above the ceiling, they got to do this, like in a hospital environment. Mike could talk to it far better than I can, but it's not easy to get up above a ceiling to fix stuff, right? There's certain areas you can't go into during the day. Sometimes it has to be done at night. So, talking to people about fixing things right away may not be the best thing. You may need to summarize it for whoever's going to be working on it. So knowing how your FM team operates, what metrics are they tracked to? Because now if this new metric isn't tracked as part of what the FM team does, and a lot of times, again, it's, hey, we bought this cool new tech, go use it. and nobody's thought about how they're going to report up on it outside of, hey, I've got a fault savings report, right? There's got to be more metrics to it than just that. And again, I go back to just understanding the rhythm of business of that team. But again, if you've got a passion and a drive to want to make things better, everything else is learnable. And I've seen champions built more than they come into the game ready to go.
Awesome.
So,
Thank you, Jeremy.
That's good. Yeah.
No, and I think that it's key. And like, as we've heard in other sessions, the champion is going to be one of the pieces that keeps this whole thing moving. All right, we have 5 minutes remaining. It's going to be our speed round a little bit. We're going to rattle through each of you, and I'd like to get your closing comments. The theme of our closing comments is, what are you hopeful for? Not just the tech, but what are you hopeful for the industry and for society? We'll be very big thinking and altruistic here. One of my favorite recent Star Wars quotes is rebellions are built on hope, and as our smart building revolution. So with that, take us through, Seth. Can you what are you hopeful for, and what do you want to leave us with today?
Yeah, I think what I'm really hopeful for is the fact that we're doing things like this today, right? We have people doing research to help operations team understand where they should go put their time and put their efforts so that we can achieve these goals that we all are trying to work towards. So I think that for me, that is really the biggest hope and drive that I continue to pay attention to, is the fact that we're all coming together from all these different areas of industry, from research, from healthcare, from normal operations teams, and we're trying to work together to achieve these very lofty goals that we have as a society to be good stewards of our land and the energy that we're using.
Excellent. That is good. Mike?
More champions.
More champion. That would help all of us. I am hopeful for more as well. That opens the industry. All right, nice. Jeremy?
Yeah, I would say faster adoption by FM teams, and more open-mindedness to the types of FDD data that you have from different FDD vendors, because they're not all equal across the board. So
Very true. All right, Jessica, what are you hopeful for? And take us home and close us out with some thoughts.
Oh, great. Thank you. I kind of mentioned that I'm very excited by this backdrop of policy and incentive environments that we have now, kind of crossed with those very explicit goal statements. So, I'm hopeful that as we get after the business of satisfying our goals, like tripling the demand flexibility potential in our buildings, that we're going to start thinking more immediately about control-enabled FDD as a scalable pathway to get there. I'm looking at things like, okay, now that we got what we wished for, which is performance standards as a policy mechanism to focus on existing building improvements, that we're going to start immediately thinking about FDD and monitoring-based commissioning. And that, so I guess my hope statement is around the convergence of kind of a perfect storm to really catalyze a lot of the activities that we've been pursuing for some time.
I think that really summarizes and brings it together. It's a little bit of the collective story of the SBX this week. I'd say it's what brings me a lot of hope for the industry, is that there is an immense amount of passion. We have super smart, passionate people that are all very engaged in this. And we can see it in our wider SBX community. And we're looking forward to where all of this energy, all the smarts that is coming together, how we continue to kind of push this forward. And advocate, like Seth said, to, be stewards of our buildings, our sites, campuses, hospitals, people, cities, all of it. This is the founding mechanism that, hopefully we can help and build a better world. With that, I thank each of you. I really appreciate all your contributions. Ton of information and insight. And, I think we're all going to be able to come back and digest all of this. Thank the audience for joining us. Appreciate all of you, wherever you may be. We're at our time, and this is all the time we get to spend with you for today. So we're going to close it out. This is the end session of the last session for the virtual days. If you haven't made plans and still able to make it, there's an in-person session in Seattle. So if you're able to join us, I'll see you down there tomorrow. And with that, we'll say good night and thank you.
Thanks all.
Thank you.
Thank you all.
Thank you.